Hi, so this is question 24. Here, fx is defined in this incredibly complicated looking way. Limit n tends to infinity, px by n, summation, this expression. The square brackets are GIF, the curly brackets are fractional part functions. And finally, after all this, it is said that function fx is differentiable. And you have to find out pq lambda. You also have to find out the inverse of f. Inverse of f fx function. So, okay, we'll look at it. And even though it looks very complicated, the question is fairly doable. So let's think about this function fx. So for x greater than 0, it is defined like this. X less than 0, it is defined like this. And our differentiability condition should give us the values of p, q, and lambda, right? So before we can do anything, we have to simplify this expression a little bit. So let's focus our attention on the positive definition of the function. When x is greater than 0, it is looking like this. We will focus our attention on this part. So let's think about it. What is limit n tends to infinity px by n summation of r goes from 1 to n GIF r square minus e power minus x plus r minus 1 by r into r plus 1 plus lambda. What is this thing? So before we can do it, what we need to figure out is what is this summation part, right? So let's understand that summation by writing a few terms, okay? So I will do that in the next screen. So just hold on to the next screen here and we'll think about the summation part. R is equal to 1 to n GIF of r square minus e power minus x plus r minus 1 by r into r plus 1. Okay, so now here r is an integer. So if you write a few terms, what it looks like is 1 square minus e power minus x plus 1 minus 1 by 1 into 2 plus 2 square minus e power minus x plus 2 minus 1 by 2 into 3 and so on, right? So notice that this minus 1 can be taken out of the GIF because it's an integer. We know the property of GIF that if x plus some n, where n is an integer, then it can be written as GIF of x plus n. So therefore, what I will do is I'll simplify this and write it like this. Plus r minus e power minus x minus 1 by r into r plus 1. And this is my summation. R goes from 1 to n, right? Now, also notice that r square plus r is always going to be an integer, right? R square plus r is always an integer. And e power minus x is greater than 0, right? Any power of e is always positive. But in this case, because x is positive, right? Because this function was defined for x greater than 0. So e power minus x is basically 1 by e power x. And therefore, it is less than 1. It is 0 to 1, right? 0 is less than e power minus x is less than 1. This is the condition for x positive. So in that case, what are you doing to this r square plus r? You are subtracting something which is between 0 and 1, right? Now r square plus r would have been an integer. So let's say that integer was turning out to be 2 square plus 2, right? That would have been 6. But you are subtracting something slightly positive but less than 1. So it will be some 5 point something. So therefore, GIF of that will be basically r is equal to 1 to n. GIF of r square plus r minus e power minus x will be simply r square plus r minus 1. Do you understand this part? I hope you do, because what we are doing is subtracting something slightly less than 1 from an integer. So obviously, it will be the next lower integer once you take out the GIF. So this is what you are getting. This is what you are getting as the expression here. So this can be easily simplified because the top part is factorizable now. So r square plus r minus 2 breaks down as factors of, actually we don't even need to factorize it because r square plus r can be written as r plus 1 minus 2 by r plus 1. So this becomes 1 minus 2 by r plus 1. And you have a summation from r goes from 1 to n, right? So this will be n minus summation of 2 times r goes from 1 to n, 1 by r plus 1, and that can be solved by telescoping series. So you get n minus 2 times summation of r goes from 1 to n, 1 by r minus 1 by r plus 1, right? So this summation will become n minus 2 times r goes from 1 to n. This summation becomes 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 and so on. It will be 1 minus 1 by n plus 1. So finally you are getting out of this, you are getting n minus 2 plus 2 by n plus 1. After doing all of these summations, you end up getting this, right? Great. So that simplifies matter considerably, because now we can say that the function was equal to limit n tends to infinity px by n, and then there was the summation thing, which we will now know the value of, which is n minus 2 plus 2 by n plus 1 plus lambda, right? For x greater than 0. So simplifying this a little bit, it becomes px minus 2 by n plus 2 by n into n plus 1 plus lambda, limit n tends to infinity. So the function has simplified very nicely. If you take limit n tends to infinity, these two terms will vanish and function becomes px plus lambda for x greater than 0. Function is px plus lambda for x greater than 0. It is also equal to q for x is equal to 0. And finally, we have to do a second summation for the x less than 0 part. And that summation was basically limit n tends to infinity, fractional part of summation goes from r1 to n, fractional part of r square plus r plus e power x minus 1 by r into r plus 1. So we'll do it in the same way as we did just now. But first we can find out some values from here itself. Since the function is differentiable, therefore it must be continuous at x is equal to 0. Continuous at x is equal to 0 as well as differentiable, and differentiable at x is equal to 0. Therefore, what you have for continuity, value of the function is equal to the limiting value here, right? So p into 0 plus lambda should be equal to q, right? So left hand limit at 0 is lambda, should be equal to the value of the function, which is q. Therefore, you get the relation lambda is equal to q. For differentiability, we will have a relation, but for that we need the right hand side as well. This part also we need to simplify to get differentiability, right? The derivative from the left hand side is basically p, right? Derivative from left hand side is p, so right hand side derivative we need to figure out, right? So let's figure out this summation now, right? How do we do that? So for this summation, what we have to do is again the same idea. Whenever you have a fractional part something, you can write it in this way. E power x minus 1 can be written as r square plus r plus e power x minus 1, the expression itself, minus gif of that, right? R square plus r plus e power x minus 1, right? So, okay, so that will help us simplify it. I will do it on the next page now. So we have limit n tends to infinity, we have r square plus r summation, r goes from 1 to n, r square plus r plus e power x minus 1 divided by r plus 1 minus gif of r square plus r plus e power x minus 1 divided by r plus 1. And this is the case when x is less than 0. So notice if x is less than 0, e power x is again, x is negative, so it's again less than 1 and between 0. Because x is negative, so it is 1 by e power x something positive, right? So it will be between 0 to 1 again, but not this time onwards, there is a plus sign here, right? So that will have some implications. So as we simplify, so what we can say is r square plus r plus e power x minus 1 is equal to r square plus r plus e power x GIF minus 1, right? And now this GIF will actually just be r square plus r. And this is a minus 1 from here. Why? Because you have some integer here and you are adding something which is between 0 and 1. So the GIF of that will be the integer part only. It is not going to reach the next integer, but it will be just this much. So simplifying this now using this result, what you will get is r square plus r plus e power x minus 1 minus r square plus r minus 1 divided by r into r plus 1 is my summation from 1 to n, where r goes from 1 to n, and finally you have to take limit n tends to infinity, right? So now clearly this and this and this get cancelled here nicely, and you get e power x, which comes out of the summation because it doesn't depend on r, by 1 by r plus 1. And this summation we have already seen. So limit n tends to infinity, we have this summation is 1 minus 1. 1 minus 1 by n plus 1, and limit n tends to infinity, that will be simply e power x. So basically the function is, this will disappear and function will become e power x for x is less than 0, right? So now I will write the full function on the next page. The function has become px plus lambda for x greater than 0. It is equal to q for x equal to 0, and it is equal to e power x for x less than 0, right? Now, continuity ensures that right hand limit here at x is equal to 0 is actually 1. RHL at x is equal to 0 is e power 0 is equal to 1. Therefore, function value at 0 is equal to q is equal to 1 is equal to lambda. Basically, RHL should be equal to LHL. LHL was equal to lambda. Then only limit exists. And once limit exists, it should also be equal to the function value, which is equal to q. So you get q is equal to lambda is equal to 1 from here, from continuity itself. And from differentiability, you should have e power x is the right-hand derivative. So e power 0 or 1 is the right-hand derivative. And therefore, that should be equal to the left-hand derivative, which is p here. So p is equal to q is equal to 1, is equal to lambda is equal to 1, right? So now the function looks even simpler. It is basically x plus 1 for x greater than 0, 1 for x equal to 0, and e power x for x less than 0, right? So that is my function. I have found p, q, lambda. So p plus q plus lambda is equal to 3, which was one of the options. And if you look at the question in the sheet, we have A, B, C options are correct. The last option D is saying that if G is the inverse of F, G is the inverse of F, then find out G dash half. G dash half is 2. Whether we have to check whether G dash half is 2 or not. So if G is the inverse of something, then I will just create some space here and let's analyze what to do about this part. If G and F are inverse of each other, we have the relation that f of G of x is equal to x, right? So derivative f dash gx, g dash x will be equal to 1, right? So g dash x is basically equal to 1 by f dash g of x, right? So if I have to find out g dash half, I'll put x is equal to half, and this should be equal to 1 by f dash g of half, right? G of half, correct. So what is g of half? So g is the inverse function. So if half comma p is a point on half comma p is a point on g, then p comma half should be a point on f, should be a point on f. By standard theory of inverse, possibly I've made some mistake here. Let me just think about it for a moment. We can find out g is the inverse of f. G dash half you have to find. So we could do it in a slightly different way also. If I do g of f of x is equal to x, we will get g dash of f of x into f dash x is equal to 1. So 1 by f dash x. Can fx ever equal half? Can fx ever equal half is the question. So this is greater than 1. This is 1. And yes, it can equal half if e power x. Yeah. So for certain value of x, you can get half, right? So let's think about it. When is e power x going to be half, right? Take log on both sides. So x is equal to log half, right? Which is equal to minus log 2. So at that particular value, fx is equal to half, right? So basically, what is the point? Minus log 2 comma half is a point on the function fx, the point on fx. Therefore, because gx is the inverse, half comma minus log 2 will be a point on g, will be a point on g of x, right? So now we'll go back to what we have to do here. So we have f of g of x is equal to x. So f dash g of x into g dash x should be 1. So g dash x should be equal to 1 by f dash g of x, and g dash half is basically 1 by f dash g of half. So this is 1 by f dash g of half is now minus log 2, f dash minus log 2. So what is f dash minus log 2? That is what we have to find, right? So f of x, this is a negative quantity. F of x is e power x for negative values of x. So therefore, f dash x is also e power x. And therefore, f dash minus log 2 is basically e power minus log 2, which is equal to 1 by 2. Therefore, 1 by 1 by 2. So therefore, it comes g dash half is equal to 2. So that is the fourth option. So notice how we have found out the g dash x. We don't have to get the inverse. We have to actually just notice that this result should give you the derivative of the inverse without even finding the inverse. So A, B, C, D, all options are right in this question. And I hope you understood how we simplified the summation earlier, and from continuity and differentiability, we were able to find P, Q, lambda, everything. I hope you understood this question. See you next time.